Problem number 21. In figure, a 15 kilogram sled is attached to a 2 kilogram sandbox by a string of negligible mass wrapped over a pulley of negligible mass and friction. The coefficient of kinetic friction between the sled and the tabletop is 0.040. Find the acceleration of the sled and the tension of the string. So in this question, you have to see the figure. There are two objects, and these two objects are connected by a string. And this string is passed over a pulley. And for this question, we no need to consider the mass of the string and the mass of the pulley. So both are considered as a negligible mass. That means when you compare with the mass of the sled and the sandbox, the mass of the string and the pulley are very, very small. So we no need to consider that for our calculation. And also the pulley is free from friction, but there is a friction between the sled and the tabletop. So that's the reason they gave the kinetic friction coefficient value as 0.040. And you can see we have to draw the free body diagram for this given figure. And after that, we have to frame the equation. And by using that equation, we have to find the answer for the acceleration of the sled. So in this question, in the first part, we are going to find the acceleration value, acceleration of the sled, which is A value. And in the second part, we are going to find the tension of the string T. So let's rewrite the given first. The mass of the sled is given. So let's take the mass of the sled as M1. So I can name as, because we have two objects. So let's take the letter we used for the mass of the sled as M1. And the letter I'm going to use for a sandbox is M2. By that, we can differentiate. Clear? And this mass M1, which is a sled mass, which is equal to 15 kilogram, and then M2, which is the sandbox mass, which is 2 kilogram. Clear? Now we have to draw the free body diagram, and also the kinetic coefficient value mu k is given as 0.040. So let's draw the free body diagram for this figure. So generally, the normal force will be acting perpendicular to the object surface, and this object is kept on the horizontal tabletop. So we have to draw the force for a normal force. Am I right? We have to draw the normal force, which is acting perpendicular to the sled surface. And then the force due to gravity for the sled is M1 multiplied by G. Likewise, when you come to the second part, which is the right hand side, that is our sandbox. This sandbox is connected by a string, so the tension will be created here, and then the force due to gravity will be in this direction, which is M2 multiplied by G. So why I just gave the name for M1 and M2? Because we no need to get confused about the force due to gravity for the sled as well as the sandbox. Clear? Because both object has different mass. That's the reason. If it is same, no issue. And also we have to consider the horizontal force. So here the horizontal force, you have a string in this direction, so tension will be created in this direction, but at the same time you have the kinetic friction, so which is Fk value. So by using this free body diagram, we have to frame the equation. So what I'm going to do, first I'm going to frame the equation for the horizontal force. So what is our horizontal force? We have tension this direction, and the Fk will be in this direction. So for the force acting in our horizontal direction, the forces in the horizontal is given as summation of f of x. So no need to get confused. Here summation is total forces acting in x direction. And this will have a kinetic friction. That means the object, the sled, having some movement in this horizontal direction. So that means we have to equate that term with a Newton's second law. So how I can write? So here we have only the horizontal force in the sled part, but there is no horizontal force in the sandbox part, right? So I have to write the horizontal force for the sled, which is given by tension minus Fk, which is equal to m1 multiplied by a. Why? Because it has acceleration. Now we have to frame the equation for the vertical forces. But for vertical forces, we have two vertical forces. One is for the sled and another one for the sandbox. So the summation of f of y we have for both sled. So what is the equation for the sled? So horizontal force is only for the sled. Am I right? But for the vertical force, you have two equations. One is for the sled and another one for sandbox. So what is the equation for the sled? So we can write the equation here as, and also the most important thing, you can see this part. You can see this part. When you just frame the equation, the normal force, that means our upward force, which is equal to downward force. Am I right? So Fn, which is equal to m1 multiplied by g. And likewise, we have to frame the equation for the sandbox vertical force. So sandbox, here you can see your m2 is greater than a tension. So that's the reason I have to write the equation here as, how we can write? I have to write this equation as m2 multiplied by g minus tension, because the acceleration will be in this direction. So which should be equated with Newton's second law, that is m2 multiplied by a. So totally we have three equations from this free body diagram. So I will explain one more time. You can see the sled region, we have horizontal forces as well as the vertical forces. But when you come to the sandbox part, you have only the vertical forces. So if you see the horizontal force for the sled, you have two equations. One is for the f of x and another one for f of y. So your f of x, which is given by, because in this direction, the tension minus frictional force, which is equal to m1 multiply, because in this direction, the acceleration will be there. So that's the reason we equate this t minus fk with Newton's second law. And likewise, if you see the vertical force of the sandbox, you can see your m2g is greater than the tension. So that's the reason we wrote m2g minus t, which is equal to m2 multiplied by a. So we have to equate this with Newton's second law. So now what I'm going to do, let's give the number for this equation. So I'm going to rewrite this equation one more time here. So by that it will be give a clear picture. So let's rewrite the equation t minus fk, which is equal to m1 multiplied by a, which is for the sled. And also one more equations you got for sled for the vertical. What is your vertical equation? The sled vertical equation, which is nothing but Fn, which is equal to m1 multiplied by g. And then for sandbox, you have only one equation, that is our vertical equation, which is m2 multiplied by g minus t, which is equal to m2 multiplied by a. So let's rename the equation as 1. This one is equation 2. This one is equation 3. Now we have to find the answer. In the first part, we have to find the answer for the acceleration, and the second part we are going to find the answer for the tension. So what I am going to do, let's find the value for the acceleration first. So for that, what I am going to do, I am going to take two equations, which is our equation 1 as well as equation 3, and then I'm going to add equation 1 and 3, both left hand side and the right hand side. So add equations 1 and 3, both left hand side and right hand side. So let's consider the left hand side. So this is our equation. So I'm going to write this equation, t minus fk plus this value. Am I right? So plus into plus, plus m2g, and plus into minus becomes minus t, which is equal to, then now I have to write add the right side forces, m1a plus m2a. Clear? Now you can see, after you add equation 1 and 3, we have plus t and minus t, so that will get cancel each other. And what is remaining? We have minus fk plus m2g, which is equal to m1a plus m2a. And here a is the common term, so I can take it outside. So that means m1 plus m2 will come inside the bracket. And then fk formula we already know, which is minus mu k multiplied by Fn, right, plus m2g. And what is our Fn? For substituting the value of Fn, what I have to do, we have to use our second equation. So we already have the second equation. So what I'm going to do, I'm going to take the second equation and I'm going to substitute here. If you substitute, what you will get minus of mu k, and when you substitute Fn, the Fn takes the value of m1g, so I have to substitute m1g plus m2g, which is equal to a multiplied by m1 plus m2. So here in this term, we can take g as a common term. So if you take g outside, what you'll get? m2 minus mu k m1, right? And the right hand side, we have a multiplied by m1 plus m2. So now we have to rearrange this equation in terms of acceleration. Therefore, the acceleration a, which is equal to g multiplied by m2 minus mu k m1 divided by m1 plus m2. So let's rewrite the given, because the mass of the sled is given as a 15 kilogram, which is given in the question, and also the mass of the sandbox m2, it's already given in the question, which takes the value of 2 kilogram, and then mu k value is already given, which is 0.040, which is unitless, and the g value we know, which is 9.8 meter per second square. Now I am going to substitute all these value in this equation, and once you substitute, you will get the answer for the first part. So let's substitute a equal to 9.8, and m2, what is m2? Our m2 value here is 2 minus 0.04 multiplied with m1, which is 15, divided by m1 plus m2, so 15 plus 2. So let's see what's the answer for the top of the equation. So a, which is equal to, so I'm going to multiply 9.8 with the bracket inside value. So let's find the answer inside. 2 minus 0.04 multiplied by 15. We got the answer here as 1.4. That means 9.8 multiplied with 1.4 divided by, when you add 15 with 2, you get 17. So therefore 9.8 multiplied by 1.4 divided by 17, I got the answer here as 0.807. 0.807. So we can write in 2 digit. So a, which is equal to 0.81 meter per second square. So that's the answer for our first part. Now in the second part, we have to find the tension. So for finding the value of the tension, you have two equations which have the letter T, right? Here T stands for tension. If you see equation 1 and equation 3, so I will write this equation 1 and 3 again, by that be clear. So what is our equation 1? Our equation 1 is T minus Fk, which is equal to m1 multiplied by a. And what is our equation 3? Our equation 3 is m2g minus t, which is equal to m2a. So for finding the answer for the B part, because in B part what we need the tension T, am I right? You can use any one of the equation. Either you can use equation 1 or equation 3. You will get the answer. So better I can do one thing. I will just use two equations. By that you will get the same answer for both. So let's take our first equation. What is our first equation? T minus Fk, which is equal to m1 multiplied by a. And then I can write the second equation also, m2g minus t, which is equal to m2a. So first of all, I'm going to solve this part. and then we will come back to the second one. Okay, so we have to rearrange this equation in terms of t. Therefore, t, which is equal to m1a, when this minus will go to the right hand side, it will take plus fk. And what is the formula for fk? Fk formula is nothing but mu k fn, and fn is already in the second equation. What is your second equation? Fn, which is equal to m1 multiplied by g. So you have to substitute this value. By that you will get the answer for fk, which is nothing but mu k m1 multiplied by g, and now you have to take this value and substitute this one here. So by that, t, which is equal to m1 multiplied by a plus mu k m1 multiplied by g, right? So here you can see both term has m1, so we will take m1 as a common. So what is coming inside the bracket? A plus mu k multiplied by g, right? So now I have to substitute the value because all these values are there. So let's substitute the value. M1, which is nothing but the mass of the sled, which is 15 kilogram, and A value we already got as a 0.81 in the part A, plus mu k value is 0.04 multiplied by 9.8. So let's see what's the answer for this. 15 multiply with 0.81 plus 0.04 multiply with 9.8. I got the answer as 18.03. So let's write the value of t. So we got 18.03. So I can write the answer as 18 Newton. So what answer we got actually here? We got 18.03 Newton. So I just write the answer as 18 Newton. Clear? Okay. Now I have to use the second equation. When you are using the second equation also, you'll get the same. What is the second equation here? This equation. So first of all, we have to rearrange this equation in terms of tension. So I have to move this to the right hand side. By that it will take positive value. And I have to move this m2a to this side. By that it will take negative value. So let's substitute the value here. So m2g minus m2a, which is equal to t, right? And here m2 is a common term. So I am going to take m2 as a common term. So inside the bracket, g minus a you will get, which is equal to tension. So therefore, tension, which is equal to, and what's the value of m2, which is the sandbox mass, which takes the value of 2, right? So 2 multiplied by 9.8 minus 0.81. So let's see what's the answer for this. So 2 multiply with 9.8 minus 0.81. I got the answer here as 17.98. So what's the answer? 17.98. So if I just want to round it this number, t, which is equal to 18 Newton. Clear? So you can see for both equation you got the same answer. That means what it exactly says, if you just go back to the figure, the tension in this and the tension in this will take the same answer. And also the acceleration of the sled and the acceleration of the sandbox is also the same value. That means A value and T value will be same for both sled as well as sandbox. Clear? So this is the answer for part B. That's it. Thank you. So here answer for T is 80 Newton. So this is the answer for the second part. That's it. Thank you.